You might have quit eating sugar, sworn off carbs, and committed fully to the keto lifestyle. But secret biological factories inside your liver are actually mass-producing sugar behind your back. Even when not a single grain of carbohydrate passes your lips, your body has an underground system designed to keep your blood sugar at a survival-ready level. Let's step inside the microscopic world of your liver to discover why and how this happens. When you restrict carbohydrates on a ketogenic diet, your primary fuel source shifts from glucose to fats and ketones. Your body adaptively burns through its stored glycogen reserves within days. To the untrained eye, it looks like sugar has been completely eliminated from your system. But biologically, your body knows that complete zero sugar status is a death sentence for specific vital organs. Your brain is an incredibly hungry organ. While it can run up to 70% of its daily energy needs on ketones, there are parts of your brain, along with your red blood cells, that absolutely demand glucose to function. They lack the cellular machinery to process fat. Without glucose, these systems would shut down completely, prompting your brain to send an urgent chemical SOS to your liver. This emergency signal triggers a remarkable biochemical survival process called gluconeogenesis. Literally translated, it means the creation of new sugar. When the external supply of carbohydrates ceases, the liver transforms into an active, self-sustaining manufacturing facility, producing high-grade glucose entirely from scratch. Breaking down this scientific miracle helps us understand its power. Gluco refers to glucose, neo means new, and genesis means creation. The liver is not just releasing stored sugar, it is chemically synthesizing brand new sugar molecules from non-carbohydrate sources that you consumed or stored as body tissue. Every factory needs raw materials. The first major ingredients for this process are amino acids, primarily alanine and glutamine. These building blocks of protein are harvested from the foods you eat, or, during periods of prolonged fasting, carefully recycled from your muscle tissue and transported directly into the liver's production lines. The second raw ingredient is glycerol. When your body breaks down stored fat, or triglycerides for energy, it splits them into free fatty acids and a glycerol backbone. While the fatty acids are turned into ketones, the leftover glycerol is immediately captured by the liver and funneled straight into the sugar factory machinery. The third crucial ingredient is lactate, commonly known as lactic acid. Produced by your muscles during physical exertion, lactate is often thought of as a waste product. However, your liver views it as valuable recycling material, pulling it from the bloodstream and converting it back into usable energy through the Cori cycle. Once these raw materials arrive, the real molecular magic begins. Through a series of highly regulated enzymatic steps, the liver reverses the normal process of sugar breakdown. It takes these non-carb fragments, restructures their carbon backbones, and painstakingly builds them up into perfect, energy-rich glucose molecules. This manufacturing process is not cheap. Gluconeogenesis is an energy-intensive pathway that requires a significant investment of ATP, the cellular currency of energy. The liver willingly pays this high-energy price, fueling the synthesis of glucose by burning fatty acids in a parallel mitochondrial furnace. This explains why your blood sugar never drops to zero, even on a strict zero-carb diet or during a multi-day fast. The liver acts as a master thermostat, releasing just enough glucose into your bloodstream to satisfy your brain and red blood cells, maintaining perfect metabolic equilibrium without causing spikes. Who manages this entire operations facility? Hormones act as the executive supervisors. When insulin levels drop due to lack of dietary carbohydrates, its counter-regulatory hormones, glucagon and cortisol, step in. They signal the liver to ramp up glucose production, ensuring the manufacturing lines run smoothly according to the body's real-time demand. A common myth in the keto community is that eating too much protein will trigger gluconeogenesis and instantly kick you out of ketosis. In reality, science shows that gluconeogenesis is a strictly demand-driven process, not supply-driven. Your liver only produces the exact amount of sugar your body absolutely requires, regardless of how much protein you eat. This complex process is actually a brilliant evolutionary adaptation. Thousands of years ago, our ancestors didn't have access to year-round carbohydrates. During harsh winters or periods of famine, gluconeogenesis was the ultimate survival mechanism, keeping the brain fueled and active so humans could continue hunting and gathering without starving. So, the next time you think about your keto diet, remember that your body isn't just passively burning fat. It is actively managing a highly sophisticated, incredibly efficient internal factory. Your liver is a masterpiece of biological engineering, proving that even when you stop eating sugar, your body possesses the miraculous power to sustain itself from within.